Hi, my name is Katrina Alexander, and this is week 4 interactive advanced presentation, fireproof balloons. For the lab, you'll need a couple of balloons just in case some of them break a little early or pop a little early. Standard lighters like a grill lighter, water, and a balloon filled with air. What we're going to be doing is we're going to fill a balloon with just air. And the next part, you'll take a balloon and connect it to a water spout and fill it maybe about halfway full with water. Okay, so in the first part of the experiment, it asked us to just simply take your lighter, hold it underneath the balloon filled with air, and see if it pops. Okay, obviously it did. These are thin balloons, so I don't know how long applying the heat. I don't think it's going to disperse that much heat or insulate it. So I have a towel down. Okay, here we go. Longer than I thought it would. Okay, so what we did, the second part, we just did the same thing, applied the heat underneath the balloon. The first part, we applied the heat to where there was air filled in the balloon. My hypothesis was as followed. I kind of thought that the balloon would insulate, or the water would disperse the direct heat somewhat. The results, you could see that the air-filled balloon popped instantly when exposed to the heat source. The water-filled balloon did not pop to the heat source immediately when placed into the water. I feel that if we would have had maybe a little bit thicker balloon, these are more like water type balloons to do water balloon games with. The balloons popped eventually after the rubber was heated to a breakage point, or to where it weakened, or the heated water could no longer rise to the top, and the cold water would flow to the bottom. The heat source would reheat it. At some point it would reach its maximum. Okay, for the explanation, the water inside the balloon was able to perform a heat sink, meaning the water was able to disperse the heat energy enough so that the latex membrane was minimally damaged instead of destroyed. This is because water has a high heat capacity, 4.18 joules per grams Celsius, compared to air, which is at 1. Again, in conclusion, my experiment did not go exactly as planned. I kind of imagined that when I watched the video that was included in our lab instructions and presentations on fireproof, he was able to heat multiple balloons for a longer amount of time before the balloon was actually destroyed. Again, I feel that this is due to the thin latex balloons that are used in my experiment. And if I would have used a larger balloon as well, then I would have had more ability to disperse the heat within the water. It was a small amount of water, which I think led to the almost instantaneous popping of the balloon. And I can give one more try here. Maybe I think this balloon was a little bit larger, so I'll give it a try. And I'm gonna try to maybe come underneath and go back and forth for more disbursement. My lighter will cooperate. Moving the heat about on the rubber, so maybe that is part of the trick, not directly staying in one place on the balloon. Okay, wow. That went well. Okay. All right, so this second part was more along the lines of my fireproof balloon. Okay, if I could have kept heating, you could see the burn marks. It probably would have eventually popped, of course. Okay, thank you. This concludes my fireproof balloon advanced presentation.